Okay, so welcome everybody to the lesson on the unit circle. So you may or may not have heard of this before, but the unit circle basically looks like this, and this lesson's all about us trying to build this thing. So yeah, if you're feeling kind of like this, don't worry. I'm going to try to walk you through it as best I can. So there's going to be a few different things we're going to go over before we get into the actual building of the unit circle. First thing is I want to make sure that I go over with you how to connect, like how the unit circle actually connects with the triangles that we've already done. And then turns out the special right triangles that we learned in a previous lesson are going to come back, and we're going to put those two together to actually build the unit circle. All right. So the connection between circles and triangles works like this. We're starting off with a circle. We're going to try to make this circle as simple as possible, meaning that we are going to place it on a coordinate plane. Um, this is called a unit circle because it is 1 unit. It has a 1 unit radius, so it's one from the center to the outside of the circle. Every single point you can imagine on this circle is 1 unit away from the center. So that's what a unit circle is. All right, you've actually learned about this ever since you were little kids, but we are going to kind of throw some extra stuff onto here. All right, so now let's say that I wanted to know where this point was on this circle. Turns out we can actually open up, or we can open up an angle up to that point and drop a line straight down from this point to our x-axis. Because what will happen then is we'll actually get a shape. That shape is a triangle. So any point that you can get on this graph, you can go ahead and just, like I said, open up the angle up to that point, okay, from the x-axis, and then drop a line. So you already have two sides of your triangle right now. You just need a third side, which is the line from the point down to your x-axis, and you get a right triangle. Now, it turns out that you have two legs. One leg is on the x-axis. The other leg is parallel with the y-axis. If you look at these two legs, you can kind of tell that whatever value these two legs are, that's actually your x and y value of whatever point that is. So let's say this leg was 5 across. That means on the x-axis you go out to 5. Say y was a 7. That means go up to 7. So it'd be 5 comma 7 because that's how far you travel. This is basically how you learned kind of first to graph a point. You travel on the x and then go up on the y. Now, one common misunderstanding is that because this side is 1, everyone thinks, or not everyone, but a lot of people think this side might be 1 and this side might be 1. Keep in mind that's the hypotenuse of the triangle, meaning these two sides are smaller than that side. So it's not the same size as x and y. But the whole point of this is basically any point that you want to find on a unit circle can be found with a triangle. Now, this is true with any point that we can think of on the circle. So even if we went way over here in the third quadrant down here, we could still move our angle over to that third quadrant. Now, it's very important that you know that when you're talking about triangle, you can make a few different triangles at this, but you always want to drop your point down from your graph or from the circle straight down to your x-axis only to make your triangles, okay? So any point that we want to try to find on this circle, we want to make a triangle by dropping one of the sides or one of the legs down to the x-axis, and then we have a triangle. And again, your x value of this side and your y value of this side end up being your point coordinates. Now, if you notice, x became a negative and y became a negative because this is in the third quadrant. Third quadrant, you have points like -7, -6, -18, -14. Those are all in this quadrant down here because both your x values and your y values are negative. I didn't write it on the triangle because triangles can't have negative sides. So, but this is in this instance, we're talking about a point. All right, and basically that's how we connect the circles with the triangles. There's a couple more points on the circle that are pretty easy to find. It's the intercepts. Basically, this point right here, you don't need a triangle for it because that is at the point 1, 0. That point up there is at 0, 1. That point over here is -1, 0. And whoops, that should be 0, -1. Sorry. So 0, -1 down here, not -1, 0. But basically, you don't need extra points, extra triangles for those points. So that's how we're going to connect circles with triangles here. Again, basically you just drop a triangle down like that. Now, turns out we kind of need our special right triangles to come back at this point in time. Mainly because right now all we know is that the radius is 1, which means that as I open up these angles, this hypotenuse always stays 1 unit. I don't know what my x and y values are, and that's basically what I'm trying to find are my x and y values. And if you remember from previous unit, the only way we can figure out these two sides of a right triangle without trig is basically the Pythagorean theorem, and you need to know at least two sides, which we don't know. So we need to use some type of trig. And that's true for any of these triangles that we try to build on here. So we're actually not going to focus on every single point that's on this circle. We are only going to focus on certain angles that we can make. And those are the ones with these 45, 45, 90, and 30, 60, 90 triangles. Main reason being because we only needed to know one of these sides to get the rest because they're all related with each other. This was done in a previous lesson, so feel free to check out the special right triangles lesson to kind of brush up on your special right triangle skills. All right, we do know a little bit more though, so we can adjust this a little bit because we know the hypotenuse. The hypotenuse is 1, and it's going to stay 1 the entire time because this is a unit circle. So we can adjust our special right triangles. I'm going to flip it over a little bit so we can kind of make it look like these triangles that are in here. So if I take my 45, 45, 90, so this is 45 degrees, this is 1 because it is the hypotenuse. So if I know my hypotenuse is 1 and it's x times square root of 2 to get my leg, like I said in the previous chapter, you would just divide by square root of 2. So it's 1 over square root of 2. We got to rationalize our denominator, and you get square root of 2 over 2, and that must be square root of 2 over 2 too. And again, we went over this in more detail in a previous thing. So basically, if this triangle was this triangle, this would be 45 degrees. Your x would be square root of 2 over 2 because that's this side length. Your y would be square root of 2 over 2. So this point right here would be square root of 2 over 2, comma, square root of 2 over 2. And you can plug it in the calculator and get a decimal if you want to, but that's basically where that point is if this was a 45-degree angle. All right. We can pull the full same move with the 30, 60, 90. We know the hypotenuse is 1. So here's my hypotenuse. If you know your hypotenuse is 1, we know that our hypotenuse is double the short leg. Short leg is across from the 30, so this must be 1/2 because double 1/2 is 1, and this side down here must be x times the square root of 3, so the short leg times the square root of 3, 1/2 square root of 3, which turns into square root of 3 over 2. Okay. Now the reason why I go over this is because if you memorize these ones, you could always build them, or you might want to memorize these unit circle triangles because we're going to use them a lot to fill this thing out. So instead of looking at this, we're going to look at these. And that would be your x and your y value if that was a 30-degree angle right here. All right, so we have our tools that we need to start building this thing. We know that we have triangles that relate to circle coordinates or coordinates that are on the circle. We know that we are going to focus in on the 30, 60, 90 and 45, 45, 90 triangles that we can build inside of this circle. So that is basically what the unit circle is. It's a bunch of 30, 45, 60, just a bunch of degrees of those just skip counting by those basically. So if you notice here, basically we have 30, 45, 60, 90. These all sound familiar because they're inside of our special right triangles, but then we kind of go beyond that. And we go beyond just the degrees inside of a triangle. So that's the nice thing about this unit circle. Now, if we examine it a little closer, there's actually a few different parts to this. We have the degrees, which is in this circle, it's kind of on the inside. Then we have radians, which is kind of the middle part right here. This is just the way this one's labeled. And then we have the actual points around the outside. All right, so there's kind of 3 layers that you have to fill in here. And what's going to happen is we're going to give you a blank unit circle, and you're going to be asked to fill it out. Now, memorizing all of these at the same time, maybe some of you can do that. I can't do it, so I had to learn how to find patterns, which is basically what math is about. So I'm going to show you the patterns that I was taught in the past that helped me with this. Hopefully this PowerPoint kind of makes it a little bit more understandable than when I learned it. But it does help to kind of see this unit circle as 2 different circles. So here's what I mean by that. I'm going to take off all that stuff. We had all of these angles that are opened up here. Now, it turns out the unit circle is actually made up of two separate circles. One is dealing with the 45-degree special right triangle. The other one is a 30, 60, 90 right triangle. And I'll show you how these fit together in a second. But once again, when you layer everything on top of each other, it is a lot. So I'm just taking this apart so that we can kind of see the patterns a little bit better. All right, so here's usually the steps I do it in. And different teachers teach this differently, but this is how I usually what helped me memorize it. First, I fill in the degrees. Second, I fill in the radians. And then third, I fill in the points. All right, and so it's a three-part process. And here's the points that I need to fill in at the very end. And then after all this, I'm going to show you how to actually use the unit circle. It's kind of pointless to build it and never know how to use it. So first off, let's fill in the degrees. We're going to focus on one circle at a time. So I'm going to go ahead and blur that one out. Let's focus on this 45, 45, 90 one first. So I have my triangle, fits nice and neatly right here. This is a 45-degree angle, okay? These were kind of pre-measured. If you kind of see that, that's why these red lines are like that, because that's where the 45, 45, 90 triangle fits. So starting at 0 degrees, and then I open it up, and I got 45. And then this next line, basically you're just going to keep counting by 45s. Is 90, add 45 to that, you get 135, add another 45, add another 45, add another 45, add another 45, and lastly, and I think I forgot to put it, but you got 360, which makes sense because that goes around and an entire circle is 360 degrees, okay? So the first step again, and you might want to print one of these up. I'll provide a link so you can do this, but I'm going to be filling this in after each part, just going to show you how I usually view this. So what I do is I start at 0 degrees, and then the 45 degrees are the ones, if you see this triple line here, you got triple lines kind of in each quadrant. This middle one is the 45. So I got 0, I got 45. This one is 90, add another 45. That's this middle one. Add another 45, you got 180, which is a half circle. Add another 45, you end up here. Add another 45, another one. And again, I forgot to put the 360. So this is 360 as well. Okay. So that's the first section. All right. And we're just going to be piecing this together. Just count it by 45s. And again, if you know the 45, 45, 90, the triangle, that's not too hard to understand. Now, all the rest is going to be from the 30, 60, 90 triangle. Now, it turns out since 60 is a multiple of 30, I don't even got to worry about the 60 part. I'm just going to focus in on this 30. So I'm going to start at 0 again. So here's my 30, 60, 90 triangle. Turns out it fits nice and neatly into a bunch of these chunks. All right. So the first one's 0. Just count up by 30s now. So 30, 60, 90, 120, 150, add 30, add 30, add 30, add 30, add 30, add 30. So just add a bunch of 30s. See if I remember 360. I did not. Oh, well. Okay. So now some of these are overlapping because 90 is a multiple of 30 and it's a multiple of 45. So that one's already filled in. So what I'm going to do is start at 0. So it's already there. Now I'm going to fill in the rest. So 30 and then 60. And makes sense that 45 is between those two. So now I'm just counting by 30s and then filling that in. Count by 30, 150 plus 30. I already have that one. Plus 30 is 210, plus another 30, plus another 30 is 270, which is already there. Add 30, and no 360 because I forgot it. Hey, look, now they're there. I guess I put it in later. All right, so, okay. So that's it. You're done with the first step. First step, fill in degrees, count by 45s, count by 30s. You have all your degrees. All right, next step, fill in the radians. Now, there are a few different ways you can do this. I'm going to try to build off previous lessons that I did. If you find other videos that show you other ways, feel free to use them. But basically, since you're already expected to know how to convert degrees to radians, just convert that first one, that 45 degrees. So from 0 to 45, I want to know what that is in radians. So from a previous video, I know I'm supposed to multiply by pi over 180 radians. Okay, the degrees cancel off, so I get 45 pi radians over 180. Simplify 45 over 180, you get 1/4. So basically you have 1 pi radian over 4, or sorry, yeah, 1 pi over 4 radians, which is just pi over 4 radians. Now we'd actually, when we write this in here, so 45 is pi over 4 radians, but normally when you see a unit circle, you don't write the word radian because there's not a whole lot of room here. So it's just assumed that this pi, anything with the pi is going to be with the radians, okay? So 45 is 1 pi over 4. Now, again, we're just going to count where we see each one of these. You could very well just do this work for every single one of your degrees, but that's horribly long. So pick up on patterns. So I got 1 pi over 4. This next one is going to be 2 pi over 4, 3 pi over 4, 4 pi over 4. So let's take a little second here. Do you see the pattern here? You're just counting up by ones on the top. It's just one piece of the 4 pieces that got split, okay? So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, and then 8 gets you back to where you started. All right, and that's filling in the pi parts. You do have to do a little bit of cleaning up here, because if you notice, you have some fractions that simplify. So the parts that simplify are basically going to be these parts I highlighted in green. So 1 pi over 4, of course, you don't have to write the 1. You can just write a pi over 4. 2 over 4 is 1/2, so that just becomes pi over 2. 4 over 4 is 1, so that's just a pi. 6 over 4, that's 3/2. And 8 divided by 4 is 2. So you just simplify those things, just simplifying fractions again, and you get that. And then that's it. That's your 45, 45, 90 piece. And again, let's fill this in. So our 45, 45, 90 was the red, I think, all these red markings. So we figured out 45 degrees was pi over 4. So first 0 pi's. So pi over 4, this is 1 pi over 4. This is 2 pi over 4, which is pi over 2. 3 pi over 4, 4 pi over 4, but 4 over 4 is just pi. 5 pi over 4 does not simplify. 6 pi over 4 turns into 3/2. 7 pi over 4, and then 8 pi over 4, which is 2 pi. All right. So that's your pi equivalencies. And again, you could always just do that conversion and get those as well. All right, so that's your pi's. Let's get into these ones. Okay. So our 30, 60, 90, again, you're going to start at this 30. So I'm going to convert that pi over 180. Multiply it out, your pi, or sorry, not your pi's, your degrees cancel off. So 30 pi rad over 180. 30 over 180 simplifies to 1/6. And then you put just 1 times pi is just pi over 6 radians. And again, we don't write the radians part, we just put the pi over 6. So this 30 degrees is the same thing as pi over 6, 1 pi over 6. And again, we're just going to count up by ones, okay, till we get all the way around. So 1 pi over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 pi over 6. All right, so you just got all these pi's over 6's. That's the easiest way that I was ever taught it. Again, if you find another way, that's great. This one just makes more sense to me. Now, again, you want to look for the parts that can be simplified. So I highlighted those in green. So 2 pi over 6, 3 over 6, 4 over 6, 6 over 6, 8 over 6, 9 over 6, 10 over 6. Those all simplify, and 12 over 6. So just simplify those fractions, and you end up with this. Okay. And then let's just fill this in again. All right. Feel free to, if you have one of these, feel free to pause the video, fill it in. So it's 1 pi over 6, 2 pi over 6, 3 pi over 6. It's already filled in. It's pi over 2. Like I said, you have some overlap up between these two separate unit circles. 4, 5, 6 pi over 6 was right here. So skipping up to 7, 8, 9 pi over 6 was this one. Already simplified. 10, 11, and then 12 pi over 6 was already 2 pi. And then this is just simplifying it. That's why those numbers changed. Okay. All right, so that's it for that. So we are done with filling in the degrees. We're done with filling in the radians. We got our degrees and our radian pieces of our unit circle. Last part is filling in the points. So filling in the points of your unit circle. Now I'm going to go ahead and clear off these pi's, because pi's and degrees are just different representations of the same thing. And I don't want too much stuff on our unit circles because it might get kind of too jumbled. I already split it into two parts. But again, let's focus in on the 45, 45, 90. Now, start off because I got to fill in all these points where my 45, 45, 90 triangles hit our unit circle. Now there's some easy ones to fill in, and I mean that literally. There's ones that are very easy to fill in. So we got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So those are the easiest parts to fill in, just because they're already x-intercepts. Now we got to find the coordinates of this. So that goes back to what I was saying when we connected the triangles with the unit circle. So we got the 45, 45, 90. So I'll pull this over here. That's 45 degrees, which means that's square root of 2 over 2 and square root of 2 over 2, which is what we found out before. And basically this leg right here is your x value. This leg is your y value. Turns out, though, it doesn't really matter in this one because they're both the same size. So your 45, 45, 90 is just square root of 2 and square root of 2, 2 over 2. So that's that, right? So that point, we already have that point. We got to come to this point over here. And what we're going to do is just take our right triangle. Just remember, you're supposed to drop it down from there to your x-axis. Okay, nice thing about 45, 45, 90s is these stay square root of 2 over 2, square root of 2 over 2. So same thing, my x-axis is this long, so that's my x value. Oh, my y value, y first, and then your x value is that one. And again, you have to throw a negative on there because if this is your origin and you're going this way, you're negative on the x's going to the left. So it has to be negative square root of 2 over 2, all right? And then just think about this point down here then. If you're going to the left and it's negative, this point you would go to the left and down. So what do you think this point is going to have as far as sign values go? Okay, we can flip that over. And this point down here, same kind of deal. We got square root of 2's over 2's. Those are going to come over here, but they both have to be negative because you have to go to the left and down. All right. And last one, same thing, same deal. You got square root of 2 over 2's, and only the x is positive because you went to the right. The y is negative down there. Now, you don't have to draw a right triangle every single time you do this. This is just to show you where these came from. If you notice, anything on the 45 markings is going to be square root of 2 over 2. You just have to figure out your sign values for them. So when we're filling these things out, first off, fill out your easy ones. Okay, so that's all around the outside. So that was that one, that one, that one, and that one. And now we're going to do our 45s, which is this part right here. Okay, so square root of 2 over 2, square root of 2 over 2. All you got to do is memorize this part. And it's pretty easy to memorize because they're both the same. Now find all your other 45 markings. We already have that one, so we're going to come over to this one right here. That one must be square root of 2 over 2 as well, but it's going to have a negative on it because it's going to the left. Find your next marking, which is down here in the third quadrant. This one's already done. We have that point. This point we can't do yet because that's part of our 30, 60, 91. We're just filling in the 45s. Okay, that's going to go down there. Both negative. This one's going to come across, reflect over the y-axis, just come straight across from this point to this point. X is positive, y is negative. All right, so we are almost done. He says 24 minutes later. All right, so that one's done. Now let's look at the 30, 60, 90. 30, 60, 90, we're going to pull the same move that we did with the 45, 45, 90, but now with this 30, 60, 90 triangle. So fill in the easy ones, put your 30-degree triangle right there, 30, 60, 90. The two sides must be 1/2 and square root of 3 over 2. So we're going to throw those into here. The x part goes on the x, the y part, the up and down part must be the y. This part is the x, all right? Now that's for that point. Now this point right here, this one actually is a different degree. It's not the 30 degree, which we got to be careful for because with the 45, 45, both the 45s were the same size. This one has two different size angles in it. So what I'm going to do is I'm going to take a look at this 60-degree triangle. So that means this is my 60 up here. That means that across from the 60 is square root of 3 over 2. So here's 60. That one must be square root of 3 over 2. The adjacent side to the 60 is 1/2. So this side is 1/2. All right. So this point up here, the x value matches my x leg, the leg that's laying on the x. My y value is the one going up and down. All right. Now we can keep doing that all throughout the circle with this triangle. But remember, the whole point here is that we're trying to look for patterns to make our lives easier. So just like how we saw over here with the 45, 45, 90, when we were just able to basically reflect the point over the y-axis and then reflect over the x-axis. We're going to pull that same move here. So the next 2 points I'm going to find are over here. So let's get rid of that triangle. So the first thing is figure out which points are reflections of each other. So if I take this point and reflect it over this y-axis, I'll end up at this point. So these are directly across from each other. Okay, so that will go over there. Okay, so this point is the same as this point, but you got a negative because it's in the second quadrant. That means that this point gets reflected directly across over to here. Okay, but you got a negative. So all you really need is these first 2 points. And if you look at these first 2 points, they're actually the same point, just flipped. So square root of 3 over 2 comma 1/2 square root of 3 over 2, which makes sense because it came from the same triangle that just got from the 30 degrees to the 60 degrees. Okay, you switch the angles on them. So these, if you memorize this first point, you flip it over to get the second point, and then you reflect over to get these 2 points. To get these points down here, you're reflecting again, but instead of reflecting across the y-axis, now you're just going to reflect straight down to the x-axis. So that first point, so these 2 points down here, we get from this quadrant. All right, so the first one is this one, because that point just drops nice and neatly down there. So this point just drops straight down because it's reflected over the x-axis. Same thing with the other one, comes straight down to here. All right, and then we're going to pull the same move, but reflect over there. Just make sure you get your signs right again. Okay, so those two get reflected over there. Come on. Oh, that went kind of fast. All right, it's PowerPoint. It's very lengthy, and it's stalling my computer out because there's so many slides. So that one goes over, and the other one gets reflected over as well, if it went. Okay, and then just make sure you get your signs right. So that's it. That's all of the points. All right. So let's take a look at this thing. Let's fill in these points. So if you know square root of 3 over 2, 1/2, just flip it over and you'll get this one, 1/2 square root of 3 over 2. Now you're just going to reflect those points over the y-axis first, and then you'll get those points. Reflect those points over the x-axis, and you'll get those points. And reflect those over the y-axis again, and you'll get those points over there. All right. And then just double check, make sure you get your signs right. And congratulations, you just filled in the unit circle. All right. Now, something about the unit circle that you need to kind of know about is this. I'm going to go into a little bit of details here so you can see why this is, but these coordinates coincide with cosine and sine of that angle. So cosine goes with x's, sine goes with y's. The way I usually memorize this is just alphabetical order. C comes before S, X comes before Y. So cosines are your X's, sines are your Y's. The reason why this works is, let's say I said cosine of 30 degrees. That'd be adjacent over hypotenuse. So that's square root of 3 over 2 over 1, which is just square root of 3 over 2. So cosine of 30 is square root of 3 over 2, which is square root of 3 over 2 right here. So cosine is square root of 3 over 2. That's why that comes in x's. Same thing with sine. That's opposite over hypotenuse. So 1/2 over 1 is just 1/2 again. That's why that's 1/2. All right. That's just the reasoning. Just make sure that you know that cosine goes with x, sine goes with y. Now, what I mean by that is, let's say I asked you for sine of 30 degrees. So basically what you would do is you would look at 30 degrees. Sine is your y value, so it's just 1/2. So sine of 30 is 1/2. And then that's it. You don't got to do anything else. Just find 30 on your unit circle. Sine goes with y, so the y value is 1/2, and you're done. Okay? That's why we like the unit circle. Special right triangles helped us a lot with 30s, 45s, and 60s, but this circle now gives us access to all these higher degrees. And plus, if you wanted like 390, you would just end up right here again, because 360 plus another 30 is 390. So this circle gives us the ability to find any angle that we want to, if they're multiples of 30s, 45s, 30s or 45s, basically. Okay. Also, it tells us, well, let's try one of those actually. So cosine of 210. So on your unit circle, go down to 210. So cosine, again, is with your x's. So at this point, I'm going to look at my x, which is this. So cosine of 210 is negative square root of 3 over 2. And that's it. You didn't need a triangle. You didn't need anything. If you take the time to fill this guy out, you will have your answers very quickly. And this is especially useful if they give you radians. So, because radians, again, is just a type of measurement of an angle. So sine of 5 pi over 3, all you got to do is go on your unit circle, figure out where 5 pi over 3 is. It's down here. So 5 pi over 3, they wanted sine. Sine is your y value. Y value is right there. So you have negative square root of 3 over 2. All right. And that's basically it. So just to recap, one more recap, okay? Because I just want to show you how this gets filled in because we went back and forth a lot. So you should know these triangles, okay, your special right triangles with the one hypotenuse filled in. First, fill in your degrees. Start off with your 45s. Fill in your radians, and then fill in your points. So first off, fill in your degrees. So like I said, start off with 45s, just count by 45s, fill those in. Fill in your 30-degree ones, just count by 30s, fill those in. Okay, then fill in your radians. Start off with your 45, so that's pi over 4, and then counting up from there. Okay, and then just make sure you simplify. That'll get you those parts. Convert 30 to pi over 6, count up by ones from there, and simplify. You'll get that part. To find the points, or actually find those easy ones first. Okay, to find the points, all you really need is this first quadrant. Starting with the 45s, it's just square root of 2 over 2, so just keep that. Let's go to the 30s now. This is square root of 3 over 2 over and 1/2. Flip it over, you get that one. Once you have this first quadrant, it's just a matter of reflecting. So all three of these points, reflect them over your y-axis, you'll get all three of those points. Just make sure you get your negatives. Then take all three of these points, reflect them over the x-axis down here. You get down here, just make sure you get your negatives. Take these 3 points, reflect them over. You get over here, just make sure you count for your negatives. And congratulations, you are now done with the unit circle. So if you have any questions or need any extra help with this, feel free to let me know. Otherwise, have a great day.